Alright, so the first question on the paper is a fraction question. So we have to first remember that when we are doing fractions, we find the LCM if we are adding or subtracting fractions with different denominators. Alright, so looking in the bracket here, we have two mixed fractions and we need to first change all mixed fractions to improper before we perform any operations on them. So we are going to change all of this. So 2 and 1/3, how we change, we multiply denominator by mixed and then add it to the numerator. So let's go with the bracket. 2 times 3 will give us 6 and 1 is 7 over 3 minus 6 times 1 is 6 and 5 is 11 over 6. So we are doing this part of the fraction first, the brackets. So now we find the LCM. The LCM for 3 and 6 is the lowest number that 3 and 6 can go into without leaving a remainder. So that LCM is 6. Now 3 into 6 is 2 times, so we multiply 2 by the numerator of this first fraction, which will give us 14. And 6 into 6 is 1 time, and 1 times 11 is 11. Now 14 minus 11 is 3 over 6. 3 over 6 can be reduced to get half. So this is 1 over 2. So we are getting 1 over 2 for the brackets, but still we have to divide by 1 and 1/3. Alright, so 1 and 1/3, when we change that to improper, we will get 3 times 1 is 3 and 1 is 4 over 3. So we can rewrite the operation as half, which is what we found for this, divided by 3 times 1 is 3 and 1, 4 over 3. Now when we divide fractions, we use the KCF method. So we keep the first fraction, change the sign to multiplication, and flip or reciprocate this second fraction. So we will get half times 3 over 4. Now we check to see if anything can be cancelled. If not, we just multiply numerator by numerator and denominator by denominator. So 1 times 3 will give us 3 over 2 times 4 is 8. So the final answer for this part is 3 over 8. Now let's look at part B. Part B, we still have to change all the mixed fractions to improper first. So let's do that first before we do any operation. For this part, we are changing this one. 4 times 3 is 12, and 12 and 1 is 13 over 3 plus 3 over 7 divided by, changing this, we will get 2 times 3 is 6 and 1, 7 over 3 times 7 times 1 is 7 and 3 is 10 over 7. So now we will do the numerator of the fraction. So we will look at 13 over 3 plus 3 over 7 first. Now remember, we are adding two fractions with unlike denominators, so we are finding the LCM. The LCM for 3 and 7 is 21. 3 into 21 will give us 7, and 7 into 21 is 3. Now 13 times 7, 13 times 7, 3 times 7 is 21, 7 times 1 is 7, and 2 is 9. So 7 times 13 is 91, plus 7, 3 times 3, sorry, is 9. Alright, so 91 and 9 will give us 100. So this is 100 over 21. So this answer is just for this section. Now we need to find the answer for the denominator. So remember, we are multiplying fractions, and when we multiply fractions, we just simply check to see if anything can be cancelled or if the operation can be reduced. If not, we multiply straight across, as in numerator by numerator, denominator by denominator. Here we can cancel 7 and 7 to get 1. We can't cancel anything else, so the answer is just 10 over 3. Alright, now we need to combine the two. We need to divide this one and that one, right? So we will get 100. Let me just write it here. Not sure, give me a second. Let me see if you're seeing it in the video. Alright, so let's do the last part of it. So it's 100 over 21 divided by 10 over 3. Remember, when we are dividing fractions, we use the KCF method, keep, change, and flip. So we are going to keep the first fraction, change the sign to multiplication, and flip the second fraction. Now we are going to check to see if we can cancel anything. Alright, so 3 can go into 21 7 times. Alright, 10 can go into 100 10 times. Alright, so 10 into itself is 1, 10 into 100 is 10. Alright, let me just, sorry. Alright, so the final answer for this would be 10 over 7, which we could write as 1 and 3 over 7 as a mixed fraction. Alright, now we are doing numbers 2 and 3. Now it says using a calculator or otherwise evaluate. So find the value of this. Now many persons will do this question and still get it incorrect, because you have to use your brackets, because the answer that you get for the numerator is what you should divide by the answer you get for the denominator. So you have to use your brackets on the calculator. So you put the numerator in brackets and then press the division sign and put the denominator in brackets. Then you press the equal sign. Right? So the final answer for this, it says you're to state your answer exactly first. So the exact answer that we get is 0.1044135676. Right? So that's a long number, but that's what we got exactly. Now you are to round off the answer to 3 decimal places. When it says state your answer or give your answer to 3 decimal places, it means you are to round off the answer to 3 decimal places. So you would count 3 places after the decimal point. And this would be the digit you are rounding, or the digit of interest. Now if the digit that follows is less than 5, the digit you are rounding remains the same. If the digit that follows is 5 or more, the digit you are rounding, you add 1 to it, right? So in this case, the digit we are rounding is 4, and the 1 to the right of the 4 is less than 5. So the digit we are rounding remains the same, and we discard the rest of the digits, or we don't write them back, right? So the final answer for this part is 0.104. Significant figure. Remember, when you're identifying significant figures, you must start counting from the first non-zero digit. So this is the first non-zero digit in the number, so this is the first significant figure. All the digits after the first significant figure are significant. So this is the first, let me erase this. This is the first, second, third, fourth, fifth, sixth. So we want to round off this value to 6 significant figures. So we're going to count 1, 2, 3, 4, 5, 6. This 3 is in the 6th significant place. So the digit to the right of it is 5. So we are going to add 1 to the digit we are rounding, which is the 3. It makes it 4. And we discard the rest of the digits. So the answer is 0.104414. Alright, so we add 1 to the 3 because the digit to the right of the 3 is 5. And remember, the rule of rounding off says if it's 5 or more, you round up. Rounding up means you add 1 to the digit you are rounding. Alright, now we need to write it in standard form. Remember, standard form is a number from 1 to a value less than 10 multiplied by 10 to a power. Now, we need to move the point to the right of the first non-zero digit. In order to move the point to the right of the first non-zero digit, we have to move it one place to the right. Alright, so we would get 1.04 if we round off to 3 decimal places. 1.04, 2 decimal places, times 10 to the negative 1. Why is it negative 1? Because we moved one place to the right. If we had to move 2 places to the left, the power would be a positive 2. So when you move the point to the right, the power of 10 will be negative. If you have to move the point to the left, the power of 10 would be positive. Let's look at another example where the power of 10 is positive. Let's say we have to write 365.3 in standard form. So we're moving this point to the location to the right of the first non-zero digit. So it's going to be between the 3 and the 6. So we would have to move the point 2 places. So the number will become 3.653. But we need to multiply by 10 to a power. So we are moving 2 places to the left. So we will multiply by 10 to the positive 2. So we're moving the point to the left this time, 2 places, so it's positive. To the right, it would have been negative. Now let's look at number 3. Number 3 is a substitution question. Alright, so basically we are substituting or replacing the value for the variable in the expression and working out the answer. So P is 5, Q is 0, R is negative 3. So we are to find 4P minus 2Q plus 3R. So 4P means 4 times P, so it's 4 times 5 minus 2Q, so that's 2 times Q, which is 0, plus 3 times R, 3R, that's 3 times R, 3 times negative 3. Now we're going to work out each of these brackets. 4 times 5 is 20. 2 times 0, anything times 0 is still 0. And 3 times negative 3 is negative 9. So this becomes 20 minus 9. And 20 minus 9 will give us 11. So that's the answer for part I. the first part. Now the second part says you are to square r. R is negative 3. So when we square negative 3, it means we are multiplying negative 3 by negative 3. So that is negative 3 times negative 3, which is positive 9. Because when we multiply two numbers with the same sign, the result is positive. Alright, now we are looking at transposition number 4. I'm just looking at 3 of the questions. Part A says you are to transpose for t. So what's in the bracket, you should make the subject. So remember, transposition involves changing the subject of the formula or the equation. If we have a formula, y equals mx plus c, then y is the subject of the formula because it is the variable on one side of the equation by itself. Alright, so we want to rearrange the formula so that t is the subject of the formula. So firstly, we need to simplify the right hand side of the equation. So we are going to find the LCM. Remember, we are adding two fractions with different denominators. So the LCM would be VT, a product of the two variables in the denominator. So V into VT is T, and T times 1 is T. T into VT is V, and 2 times V is 2V. All of that is still equal to 1 over R. So 1 over R is equal to T plus 2V over VT. At this point, we are cross multiplying. That means we're multiplying the diagonals. Numerator by denominator, denominator by numerator. So 1 times VT is VT because 1 times anything is the same thing. R times T plus 2V. R times T plus 2V. Now remember that when we multiply a variable by a bracket, we need to expand. So we're going to expand the right hand side of the equation to get R times T, which is RT, R times 2V, which is 2RV. Now we need to group the terms. Now we need to group the terms with T in it on the left hand side. So the terms with T in it are VT and RT. So VT is already on the left, so we're just gonna get R on the left hand side as well. RT on the left hand side as well. So RT is being added on the right, so if it goes to the left, it will be subtracted. So VT minus RT is equal to 2RV. Now we need to factorize so that we have only one T on the left hand side. So if we look at VT and RT, what is common is T. Alright, so we are going to factorize so that we have one T on the left hand side. So T into VT is V, T into RT minus RT is minus R, and that's equal to 2RV. Now we can eliminate V minus R, that is being multiplied by T. So in order to eliminate V minus R from the left hand side, we have to divide both sides by V minus R, or we could divide the right hand side by V minus R. So T is equal to 2RV over V minus R. Alright, so that is what T is equal to. Now we need to make Y the subject here. It's a similar procedure. We have two Y's in the equation, but we need to make only one y the subject. So we're going to do this same procedure. First thing we're going to do is to cross multiply. So x over 1 equal y minus 2 over y minus 3 is the same as what we had before. So 1 times y minus 2 will give us y minus 2. X times y minus 3, we express it in that way, and you know we have to expand. So x times y, just writing back y minus 2 on the left. X times y is xy. X times minus 3 is minus 3x. Now we are going to group the terms with y in it on the left hand side. So we have this term with y in it and this term with y in it. So xy, we're taking it to the left hand side, and minus 2 we'll take it to the right. Alright, so y minus xy, because xy was being added over here because it's a positive xy, right? It's equal to minus 3x plus 2. Alright, this 2 was being subtracted, so when we take it to the right hand side, it will be added. Now we need to factorize the y. So what's common between these terms, 2 terms, is y. So y into y is 1. Y into minus xy is minus x. That's equal to minus 3x plus 2. Now we can eliminate 1 minus x by dividing it on the other side, because it's being multiplied on the left hand side of the equation. So y is equal to minus 3x plus 2 divided by 1 minus x. And that's it. Alright, so we are still at transposition, but I'm just introducing a new method of transposing when the variables are undergoing different operations. Right? So we want to make t the subject here, but how do we know what to eliminate first in order to isolate t on the right hand side by itself? Because t is squared is being multiplied by a, and then u is being added. So we're going to use a method called the onion skin method to decide what to eliminate first and what to eliminate next. Alright, so we have to bear in mind opposite operations when we are doing transposition. So the opposite of addition is subtraction, opposite of multiplication is division, opposite of the square of a number is the square root of the number. Right? So the first thing that we're going to do, we're going to circle the variable that we want to make the subject. So we're forming onion skins. Right? So we're circling t. The next thing that was done to t is that it was squared. After that, it was multiplied by a. After that, u was added. Right? So, as you can see, we're forming something looking like an onion. So, in order, just like how we peel the onion in order to get to the center, this is what we would do here. So, we would eliminate the outermost skin first. Whatever variable is left uncircled is the first variable you're going to eliminate. Now u is being added on the right, so if we are going to take u to the left hand side, we must subtract. So it's going to be v minus u is equal to at squared. Next, we're going to remove this layer. We are left with a uncircled. So a is the next thing we're going to eliminate. But a is being multiplied by t squared. So if we eliminate a on the right hand side, we will have to now divide on the left hand side, because the opposite of multiplication is division. So it's going to be v minus u over a is equal to t squared. Now we are going to eliminate the next skin here. So we are left with the square outside. So we need to eliminate the square from off the t. Alright, so remember that we have the opposite of the square of a number is square root. So in order to eliminate the square, we need to square root all that was on the other side. So we will get v minus u over a is equal to t. So that is the final answer for this question.